In this video, we will do some more examples of arithmetic progression. So our first example is find the sum of the first 20 multiples of 5. So the solution is, so first we have to write the arithmetic progression. So it says first 20 multiples of 5. So it means 5 ones are 5, 5 twos are 10, 5 threes are 15, 5 fours are 20. So it goes like that, and in the end we will write 5 into 20, which is the last multiple. 5 into 20 is 100. So here you can see the first term is 5 and the common difference is 10 minus 5 is equal to 5, which is same in all the terms. As you can see, 10 minus 5 is 5, which is d1, the first common difference, and the second d2 is 15 minus 10, which is 5, which is same. So here, as you can see, our last term is 100, which is also known as the nth term. So an is 100. So as we know, the formula for the nth term is a plus n minus 1 d. But here we don't need to use that because we have to find the sum of the arithmetic progression. So the formula for the sum of the arithmetic progression is n by 2 2a plus n minus 1 d. So the value of n we already know, it's 20, because they want us to find the first 20 multiples of 5. So it means n is 20. So the first term we already know is 5, n is 20, and the common difference we already calculated, which is 5. So it becomes 2 into 10 is 20. So here it is 10. 2 into 5 is 10 plus 20 minus 1 is 19 into 5. So 10 plus 95. 10 plus 95 is equal to 105. So the final answer is 1050. So the sum of this arithmetic progression is 1050. Let's do one more example. So the second example is find the sum of the following arithmetic progression which is 9, 15, 21, 27. It goes on, and the total number of terms is 14. So the solution is, so here you can see in the given arithmetic progression, the first term is 9 and the common difference is a2 minus a1, which is 15 minus 9, which is equal to 6, and the total number of terms is given as 14. So it means the value of n is 14. So we can directly use our sum formula, which is Sn is equal to n by 2 2a plus n minus 1 d. So here we know n is 14, first term is 9, and our common difference is equal to 6. So here 2 into 7 is 14, 2 into 9 is 18, plus 13 into 6. 13 into 6 is equal to 78. So 78 plus 18 is equal to 96. 96 into 7 is equal to 672. So the final answer is 672. So the sum of the given arithmetic progression is equal to 672. Let's do one more example. We have to find the sum of the following AP, which is 15, 19, 23, 27. The last term is given as 75. Let's solve it. So here you can clearly see the first term is 15 and our common difference is a2 minus a1, which is 4. So here the last term is 75, which is also known as nth term, is already given, which is 75. As the formula to find the sum of the arithmetic progression is n by 2 2a plus n minus 1d. Here we already know the values of first term and the common difference, but we don't have the value of n, which is number of terms. But we already have an, and the formula for the nth term is written as a plus n minus 1d. So we can use this formula to find the value of n, because the value of nth term is already given, which is 75, and we have the value of first term, which is 15, n minus 1, and the value of the common difference is 4. So here 75 minus 15 is equal to n minus 1 into 4. 75 minus 15 is equal to 60, which is equal to 4 times n minus 1. The n minus 1 is equal to 60 by 4. N minus 1 is equal to, as 4 into 15 is 60, so n minus 1 is equal to 15. So the value of n is 15 plus 1, which is 16. So as we calculate the value of n, which is 16, with the help of the nth term, so we can easily find the sum of this arithmetic progression. So the formula for the sum is n by 2 2a plus n minus 1d. Well, if we have the first and the last term, we can also use the other formula, which is Sn is equal to n by 2 a plus l. This one is really easy to calculate as compared to the previous one. So the value of n is 16, and our first term is equal to 15, and the value of the nth term or the last term is already given, which is 75. 2 into 8 is 16, so 8. 75 plus 15 is equal to 90. and 90 into 8 is equal to 720. So the sum of the given arithmetic progression is equal to 720. Let's solve one more example, which is we have to find the sum of first 30 terms of the arithmetic progression, which is given as 50, 45, 40, 35. So the solution is, so here you can see the first term is equal to 50. The common difference is equal to 45 minus 50, which is equal to minus 5. So here they want us to find the sum of the first 30 terms of the AP. So it means the number of terms is already given, which is 30. So this is really easy to find because we can use the sum formula directly because we have all the values. N by 2, 2a plus n minus 1d. So here the value of n is 30. The value of first term is 50. Again it's 30 minus 1, and the common difference we already calculated, which is minus 5. 2 into 15 is 30. 50 into 2 is 100 plus 29 into minus 5. So here 100, 29 into minus 5 is minus 145. So 100 minus 145. So 100 minus 145 is equal to minus 45. So 15 into minus 45. So as 15 into minus 45 is equal to 675. So our final answer is minus 675. The sum of the n terms of the given arithmetic progression is minus 675. Let's solve one more example. So in this example, the an, which is also known as the last term, is given as 20. The common difference is given as minus 1. The number of term is given as 17. We have to find the first term. So the solution of this example is, as the nth term is given as 20, the formula for the nth term is written as a plus n minus 1d is equal to 20. The first term is we have to find. So n is given as 17. The common difference is given as minus 1 equal to 20. So here a minus 1, 17 minus 1 is 16 is equal to 20. A minus 16 is 20. So the value of a is 20 plus 16, which is equal to 36. Let's solve one more example, which is find the first negative terms of the sequence, which is written as 20, 19, 1 by 4, 18 1 by 2, 17 3 by 4. So the solution is, so first we will write the arithmetic progression 20. So 19 1 by 4 is calculated as 19 into 4 plus 1 upon 4. Similarly 18 1 by 2 is 18 into 2 plus 1 over 2. And similarly 17 3 by 4 is calculated as 17 into 4 plus 3 upon 4. So our arithmetic progression is 20. So 19 into 4 is 76. 76 plus 1 is 77. 77 by 4. The next term is 18 into 2 is 36. And 36 plus 1 is 37. The third term is 37 by 2. 17 into 4 is equal to 68. And 68 plus 3 is equal to 71. So our fourth term is 71 by 4. So this is a following AP in which the first term is 20 and the common difference we will calculate, which is A2 minus A1. 77 by 4 minus 20. So here we will take LCM, which is 4. So 77 minus 20 into 4. So 77 minus 80 divided by 4, which is equal to minus 3 by 4. So a common difference is equal to minus 3 by 4. So they want us to find the first negative terms of the given sequence. So we have to suppose that the nth term of the given AP is the first negative term. If the nth term, which is an, of the given AP is the first negative term, then the nth term, which is an, must be less than 0. So here we know the formula for the nth term is a plus n minus 1d less than 0. So as we know the value of a is 20. The value of common difference which we already calculated is minus 3 by 4 less than 0. 20 minus 3 by 4 into n minus 1 less than 0. 20 less than 3 by 4 into n minus 1. So if we'll calculate n minus 1, 20 into 4 by 3. So here n minus 1 greater than 80 by 3. So n will be equal to 80 by 3 plus 1. So n is greater than, so here we will take LCM. So 80 plus 1 into 3. N is greater than 83 by 3. So if we divide 83 by 3, so here you can see 3 2s are 6, 2. So here comes the 3. 3 sevens are 21. So our remainder is 2. So we can write this as n is greater than 27 2 by 3. So as the n is greater than 27 2 by 3, so we can say that the 28th term of the given sequence is the first negative term. Let's solve one more example, which is find the first positive term of the AP, which is written as minus 11 minus 8 minus 5. So the solution is, so here the first term is minus 11 and the common difference we will calculate, which is a2 minus a1. So minus 8 minus 11. So minus 8 plus 11 is 3. So our first term is equal to minus 11 and the common difference is calculated as 3. So they want us to find the first positive term of the given arithmetic progression. Let us suppose that the nth term of this given AP is the first positive term. So it means the nth term will be greater than 0, as the formula for the nth term is a plus n minus 1d. So as the value of a is minus 11 plus n minus 1 and the value of common difference, which we already calculated, is 3. So minus 11 plus 3n minus 3 greater than 0. So minus 11 minus 3 is minus 14 greater than 0. So 3n is greater than 14. So n is greater than 14 by 3. So if we divide 14 by 3, comes out to be 3 4s are 12, 2. So we can write this as 4 2 by 3. So here we can see that the fifth term of this arithmetic progression is the first positive term. Now let us find the fifth term of this AP. So as the formula for the nth term is a plus n minus 1d. The fifth term, it will be a plus 5 minus 1d, which is a plus 4d, as the value of a is equal to minus 11, the value of d is 3. So the value of fifth term is 11 plus 12, which is 1. So the fifth term is 1, which is the first positive term.